And the ideal gas law says that P times V equals N times R times T. So let me tell you what these different letters represent. So if we have what's called an ideal gas, and these are the ones, the noble gases follow this exactly, but with slight modifications. This is true of many other gases. So for the most part, we can pretend like it applies to any gas we work with. So maybe nitrogen gas or neon, helium, etc. It's a way to relate the pressure that a particular gas is experiencing to the volume in its container. So if we take the pressure on a gas, the P is for pressure, we multiply by the volume of that gas, especially think about it if it's being contained, then that's equal to N. N is the number of moles. So another way to think of it is how many atoms of gas we have, times R. R is a scale constant based on the gas itself, times the temperature. So the idea being the warmer we are, that impacts the pressure that a gas is going to exert in a particular situation. And this is actually why we find that it's colder in the mountains, because sort of the volume that gas can take up in the mountains in the atmosphere is pretty much constant, but the pressure is less because of the fact that we are farther away from the earth and we don't have some of those other atmospheric things pushing down on us. And so that is actually why the temperature is cooler when you get to the top of the mountain, even though it's closer to the sun. It's because the gases can spread out volumetrically and there's less pressure. So just a cool little fact. This is why when you go to high altitude too, the air pressure is less and it can often impact people in their ability to breathe because the air is less dense. So using the ideal gas law frequently, like this is the classic high school chemistry problem, I might say. If the volume of the container that I have the gas in is 10 liters, and this is the temperature, and I know this is the rate, and the number of moles is given, then tell me what's the pressure. That's a really classic problem in science. So to solve that problem, I need to take a formula like this and solve it for the pressure. So let's just practice solving this for a couple different variables. So first, let's go ahead and solve this for P. Remember, P is pressure, so it's telling me how many pascals of pressure or atmospheres, depending on the units we're using, that gas is exerting in the space that it contains. Then try solving it for T, just so we can see the difference. And then the one that, if you knew all those values, would be the most helpful for understanding how that gas is different from another. Let's go ahead lastly and solve for R. And what we'll see when we get into some of our later work in algebra as well as in our regular math class is that often it's seeing how does a change in one of these impact a change in another that's so valuable. We're talking about direct or indirect relationships. And this is totally high school chemistry, but also absolutely positively what you do in calculus. So you are getting lots of advanced math for free in a really simple algebra equation here. Let's solve this problem. So P times V equals N times R times T. Take a moment and type a guess for what you might have as your first step in the chat. Next, let's go ahead and work. So I want to isolate, meaning I want that to be the only variable, P, if I'm trying to solve the first version of this problem. So I look at P and I notice that the operation that links P to other variables on the left-hand side is multiplication. So to solve this problem, I'm going to divide both sides of my equation, PV equals nRT, by V. So I'm dividing by the volume that takes up. And what I am left with in this case, because it wasn't a lot of steps, is that P equals nRT over V. And so one thing we see really clearly from this is that as the volume increases, the pressure will decrease. Because if you're dividing by V, the bigger V is, the bigger the denominator of something is, the smaller the overall quantity is. And we can learn that from this rearranging formulas. Let's try the second example. Let's solve for T. So I have PV equals nRT. Now I need to get T by itself. T is multiplied by everything on the right-hand side. So both N and R are getting in the way. So if I divide both sides of my equation by NR, then what remains on the left is this PV divided by N times R, and what's left on the right is T.